All right, so yesterday I just had asked you to complete this worksheet, getting a little more familiar with your reference table page 5, which we used a long time ago for latitude and longitude, but now we're using it to get comfortable with plate tectonic stuff. Sorry, mine's all messy. I decided to write all over it, but that's what you guys can do. You're welcome to write all over your reference tables. They are yours. If you ever need a clean copy of them, just let me know. So this reference table kind of takes what we've done the past few weeks, or last week, I mean, and kind of puts it right on the right in here. You don't even have to memorize a lot because of the key down here. So starting off, that's what they wanted you to check was draw the symbol for each boundary / activity types listed below. Make sure to label when necessary. Convergent, have an overriding and a subducting one. So the first was the converging. So hopefully you had the line with the little boxes on it. The boxes tell you which plate is overriding, which you should have come into contact with a little bit later in the reference table. So the side with the boxes is the overriding. And the side without the boxes is the subducting. I'm assuming you can figure out what overriding and subducting mean. Yeah. So overriding, which plate, what's that plate doing? Going over the other one. And subducting, like submarine or subway or subpar, means it's below. So the subducting one is the one going under the other plate. For the divergent plate boundaries, this one has those double lines going diagonal down, then the solid, I don't know how you want to describe that. So you did want to draw something that resembled this symbol here for the divergent. Again, remember those just mean the plates are moving away from each other. Transform, those are when the plates are sliding past each other. So it's just a line with those arrows going in opposite directions past each other. Complex or uncertain. I don't know if I even mentioned this one on Friday when we were looking at this. I'll tell you, somebody knows what's going on there, but it's too complicated to describe to 10th graders. So we just leave that as listed as complex or uncertain. It's just the dashed line. And the hot spots, which we're going to start talking about tomorrow, are these starburst type shapes. So hopefully your answers looked something like that. Maybe you can do the hotspot better than I can. No, can't. Yeah, that's an impossible shape for me, at least. All right, then they asked you about North America and Eurasia. So here is North America. Here is the Eurasian plate. So you should notice that there was a dotted line between those two. So that's a complex. And then you do the same thing for South America and Nausicaa. You should see that that's a converging plate boundary. And if you keep going, you'll see that San Andreas Fault is a transform. Antarctica and the Indian Australia, that's a divergent. Sorry, I was getting lazy. Eurabian and Eurasian, that should have been a convergent, not complex. And then we've got transform and convergent again, yes? That, so, oh, over here. Yeah, duh. So here's the North America. Here is also the Eurasian plate. So I'm going to say it should have been both. Way to go, Sam. I did not notice. Way to pay attention to details, or did you only have divergent? Okay, well, that's not the wrong answer either. So we're just as good. We just looked in different spots. Any other questions? That was a great one. Okay, then you just had to go to each of the subducting plates listed and tell me which one was the overriding and which one was the subducting. So again, you found the two plates. Here's Eurasia. Here is the Indian Australia plate. You should see that those are converging plate boundaries. And the I always call them top hats. And that kind of helps me remember. So these kind of remind me of top hats, and they always go on the, like the top, the one that's on top. I don't, anyway, that's on the Eurasian plate. So I went through and I just listed which one was the overriding plate, meaning the other one is the subducting. If you did fill that in, that's better. So in this case, in B, I had the Pacific and North American. The North American was the overriding. The Cocos and the Caribbean was overriding. Nausicaa and South America was the overriding. Juan del Fuego plate and North America, the North American plate was overriding. The Eurasian and the Fiji. Did you guys all have that or anything? Did I screw up again? I literally just rushed through the answer sheet, so I could have definitely screwed up. Good. All right, for the latitude and longitude, this should have been review. You don't have to have the exact answers I do, but make sure your north, your south, the east, and the west are correct. And for the ones in the south, make sure you estimated correctly. I want to do this one, the Tasman hotspot. Part of the trouble is probably finding everything. And that's kind of why I gave you the assignment, was just to get you more used to using this reference table. So the Tasman hotspot, I drew my line over and I see it's really close here to the 40. But notice that it's between 30 and 40, not between 40 and 50. So this number had to be less than 40, hence my 37 degrees south. A lot of people would have put 42 or something like that, and that would have been wrong because that would have been closer to the South Pole, not closer to the equator. So I had 37 south and 157 east. Easter Island, 25 south and 115 west. Hawaii, 23 north and 155 west. St. Helena hotspot, 15 degrees south and 15 degrees west. 35 north and 20 west. Iceland, around 65 north and 20 west. 52 south and 5 east. And then I had the equator, 0 degrees and 100 degrees west. Does anybody need me to go over any of those? Did I screw any of them up? All right. How about this? Were you able to answer why does Japan experience a large amount of tectonic activity while the East Coast of the United States experiences barely anything? Yes, that's the key. You have to have something about being near the edge of a plate or on a plate boundary, or like TJ said, he used the word border. What you cannot say is Japan's on a plate and we're not, because we're still on a plate. We're just near the middle of a plate. So that's actually another way people would have answered it, is the East Coast of the United States is on the middle of a plate, not near a boundary or an edge. So that's one time where your wording will be important. Have to talk about being on the edge or the boundary or a border. All right, quickly with the rest of it. Again, I'm guessing at this point, if you did it, you had it right. The Pacific plate is Hawaii. Nausicaa plate is the Galapagos. Eurasian is Iceland. African, there were 2, the Canary Islands and St. Helena. Good so far? This one, the Mariana Trench, is between the Philippine and the Pacific plates. The Tonga is between the Pacific plate and India and Australia, and Peru-Chile Trench is South America and Nausicaa. The ridges, especially the mid-Atlantic ridge, that one had multiple answers. It was between North and or South America and Eurasia. So notice the mid-Atlantic trench ridge separates either North America and Eurasia or South America and African. I guess it's not South America and Eurasian at all, but it is 2 separate answers there. So either one would have been fine. So I should add African. The Southwest Indian Ridge is Antarctica and Africa. The Southeast Indian Ridge is Antarctica and Indian. Mid-Indian is African and Indian Australia. Good? Did I screw up at all? All right, and these were the same. And then hopefully you were able to realize that the mid-ocean ridge symbol is exactly the same as the divergent plate boundaries. That was the connection I wanted you to make there. All right, what do the arrows show? They show you the relative motion. Trenches, they're moving together. So a trench is a convergent plate boundary, moving away at the ridges, so that the ridges, they're going away from each other, which makes them a divergent plate boundary. And then the San Andreas Fault is transformed. Then you were supposed to use this picture here to answer these questions. Draw 2 arrows at each area A, B, and C to illustrate the plate movement. So you had to match these places up with your reference table. And hopefully when you did that, you realized here, I guess I started at area B for some reason. The arrows should have been pointing together. Area C, they were moving apart. And area A, you should have noticed, was the San Andreas Fault. So North America is going down. The Pacific is going up. So what does that make area A? That's a transform. Area B is a convergent. And area C is a divergent. And then finally, the movement of crustal plates is most likely caused by, I have not talked about this even a little bit yet. Did anybody know? So I heard some 1s, I heard some 2s, and I heard some 3s and 4s. It is 4. It is the convection currents in the mantle. If you got it wrong, that's okay. I didn't teach it to you yet. All right, so that was your homework due today. We're going to kind of switch back to a little bit more of the learning that we've been more accustomed to in this class. So I'm going to have you guys come grab, our regular old packets for this chapter. I'll deliver. Just in case they show, I'm going to include one for the people who are, somebody normally is behind you. I can't picture off the top of my head. Oh, yeah. I don't picture her. I just can't picture who's sitting where. I can't believe you. Did somebody sit behind you? Yes. These packets are huge. I apologize. There's a lot of reference table stuff. Hopefully not everybody's here because apparently I did not make enough packets in this class. Yeah, this is a large packet. I apologize. Well, I apparently have no copies. So we're going to get started with it. Oh, I should have done this already. I expected everybody back 10 minutes ago, so I'm not sure. All right, I always like to start this chapter off with a good old quote from Shrek. Shrek's my buddy. No, I love Shrek. Ogres are like onions. Who remembers why? Wow. Okay. Wow. Not because they smell bad? No. Oh, why are we changing our? There's nothing there, but you can turn off the lights.
Pet parents know that bath time can be a messy time. That's why Tractor Supply's pet wash stations make it easy to clean pets. At just $9.99 a wash, they're convenient, affordable, and no appointments needed. Plus,
Okay, let me get this straight. You're gonna go fight a dragon and
Hey,
rescue a
you guys
princess just so
forgot.
Farquhar to give you back a swamp, which you only don't have because he filled it full of freaks in the first place. Is that about right?
You know what? Maybe there's a good reason donkeys shouldn't talk.
I don't get it, Shrek. Why don't you just pull some of that ogre stuff on him? You know, throttle him, lay siege to his fortress, grind his bones to make you bread. You know the whole ogre trip.
Oh, I know what. Maybe I could have decapitated an entire village and put their heads on a pike, got a knife, cut open their spleen, and drink their fluids. Does that sound good to you?
No, not really, no.
For your information, there's a lot more to ogres than people think.
Example?
Example? Okay, ogres are like onions.
They stink?
Yes. No.
Oh, they make you cry?
No.
Oh, you leave them out in the sun, they get all brown, start sprouting little white hairs.
No! Layers! Onions have layers. Ogres have layers. Onions have layers. You get it. We both have layers.
Oh, you both have layers. Oh. You know, not everybody likes onions. Cake! Everybody loves cakes. Cakes have layers.
I don't care what everyone likes. Ogres are not like cakes.
You know what else everybody like? Parfaits. Have you ever met a person you say, hey, let's get some parfaits? They say, hell no, I don't like no parfaits. Parfaits are delicious.
No! You dense, irritating miniature beast of burden. Ogres are like onions. End of story. Bye-bye. See you later.
Parfaits may be the most delicious thing on the whole damn planet.
You know, I think I preferred your humming.
Do you have a tissue or something? Because I'm making a mess. Just the word parfait make me start slobbering.
All right. So that's our good old Shrek, just to remind you. Stop. Where's it playing? I know, but it won't let me escape. There we go. I don't know. Okay. Okay. Whew. Okay, well, that was interesting. Okay, so. So since Shrek is like an onion, why do I say the earth is like an onion? Oh, you guys got it. The earth has layers. I'm assuming you remember some of the layers from your olden day education, right? There's fancy names for those layers. We know cross, mantle. What did I think that was said? Okay, ozone is not part of the earth, that's part of the atmosphere, which we'll get to. So we have crust, mantle, inner core, outer core, anything else? Oh, where are you getting your information from? Oh my gosh, I told him not to start it. Crazy. All right, anyway. So some of you already know because you started it. The earth actually has 6 layers. This is not telling you that your old teachers lied to you. So if you notice, there should be 6, right? 1, 2, 3, 4, 5, 6. Yes, there are 6 layers going down the left side of your notes. If you don't catch all 6 of these, now you can catch them as I go through each slide. But I just wanted to say, your 6th, 7th, 8th grade teachers did not lie to you. They just didn't tell you the whole truth. Or like I've been saying, they introduced it and now we have to 10th grade it up. So now we're going to introduce a couple new layers of, again, not new, just part of the old layer. So before you only talked about the crust, now we're going to talk about the lithosphere. The asthenosphere is probably new, and the fact that we have a stiffer mantle might be news to you. So again, if you don't have all of these, you're going to catch them as we go. So we're going to start with the lithosphere, which we did talk briefly about already, but I don't know if I ever exactly told you what it was. So the lithosphere, so that goes on the left side, and then the notes for the lithosphere go on the right side there. This is the solid outer layer. It includes the crust, which I'm assuming you guys remember that the crust, just like the crust on bread, is on the outside. So the lithosphere includes the crust and then what we call the rigid mantle. Do you guys know what the word rigid means? No, okay, it has ridges. That's not quite what rigid means. Stiff, solid. So again, it's just another way for like completely solid talking about. So yeah, solid rock. So again, the lithosphere is 100% solid. It does include the crust, which I'm assuming you guys know that crust is solid. We're walking on it. And then the new word there is rigid mantle, which again just means solid part of the mantle. So the crust and rigid mantle, again, is solid. I asked you to open your reference table to page 10. If you didn't notice that, I really meant it. Oh, the other thing I wanted to point out, guys, is underneath the ocean. What's underneath the ocean? So if I was to take a submarine, put it out in the ocean, and sink it to the bottom of the ocean, what would it hit eventually? No. Rock and sand first. I guess there's one place in the ocean that we might hit some lava, or a couple places, but mostly we're going to hit the ocean floor. And the ocean floor is solid rock. So guys, the lithosphere extends beneath the ocean. So there is solid ground underneath the ocean. It is still the crust and rigid mantle underneath the ocean. So it is still part of the lithosphere. Yeah.
It's basically the same as the ocean from the water as the lithosphere, like water.
Right, right. So there's lithosphere and hydrosphere sitting on top of it. Yeah. Yeah. So yes, and hopefully you realize that. And if you didn't, now you know that the whole outside of the earth is solid rock. Yes, there's water sitting on top of some of it, but underneath that is solid rock. I like to point this out. This is an apple. And yeah, and I cut it in half. Okay, well now you do. So what you are supposed to be seeing here is if the skin of the apple, that pretty accurately represents the lithosphere. The mantle is represented by the white part of the apple, and the inner and outer core represented by the core of the apple as well. This is a pretty accurate representation. Notice how thin the skin is. That is supposed to be showing you how thin the lithosphere is. It is pretty close to that skinny. So the lithosphere is really, really thick. Now okay, so I guess I did not put a picture of the reference table here, so I'll come back to this. I had asked you to open up to page 10 of your reference table. And here on page 10, though page 10 has kind of three parts, a picture and two separate graphs. They all go together. The first thing I want to focus in on is the picture. What does this picture kind of look like? Okay, it does look like the earth. What? God, definitely looks like pizza. Okay, okay, but what about this? Does it kind of look like this? No. Okay, I think it does. What if I cut the apple into that quarter like that? Still doesn't remind you at all of that picture part on the graph? Okay, well, it's supposed to. Okay, so this is if I took the whole earth, cut it in half just like the apple, so you're seeing the inside of the earth, and then just took a quarter of it to show the different layers, just like I did on that apple here a second ago. If I was to cut this, we could see then we'd have the skin, the part you eat, the beginning of the core, and then you'd get to the dead smack center core. So that reference table is just like the whole earth, or should be. So again, if this was the apple, we've got the skin, the part we eat, the start of the core, and then the dead smack center of the core. Again, this is showing you, giving you an idea about the picture. This is showing you how thick each section is. Now, the lithosphere is mentioned right here. See how it says lithosphere? What's this bracket telling you about the lithosphere? So it's showing you exactly what the lithosphere is made out of. So here's the lithosphere. This bracket is telling you it's made out of the crust and rigid mantle. I feel like this is, again, I call this your cheat sheet. I call it your cheat sheet for a reason, because it tells you the answer. What's the lithosphere made out of? The crust and rigid mantle. Now notice that the crust is pointing to the black line there, and the rigid mantle is pointing to the white line. What do you notice about that black and white line compared to the rest of the earth? It's really itty bitty teeny tiny. That is accurate. The crust and rigid mantle are itty bitty teeny tiny compared to the rest of the earth. All right, let's keep going with these different layers. So the next one in your notes is just what the crust is. So the crust, please label that it is part of the lithosphere. It is the rocky shell that floats on the asthenosphere. It includes the ocean floor. Okay, the next one is the asthenosphere, which you may not have even realized how to say that. I think I was saying it correctly. Asthenosphere. It's also referred to as the plastic mantle. It's made out of molten material. Now, why they call it the plastic mantle doesn't so much help us anymore. Because when we think of plastic, we often think of like your plastic water bottles that are pretty darn solid. But right. Or what we're also thinking of, do you guys know slime? You guys are all slime fans. You're the same, around the same age as my kids. It was a huge fad, right? It still is. You were never allowed to play with slime. Then congratulations to your parents. They won. I didn't win. I have since outlawed slime in my entire house. Many of you will probably understand because you guys paint it everywhere. But slime, actual homemade slime, is considered a polymer. It's plastic. So picture slime, that ooey gooey. Is it a liquid or is it a solid situation? Slime. Kind of like both. That's actually the answer I wanted. It's not quite a liquid. I can't pour it out like water, but it's also not like a solid where it doesn't move at all. So it's kind of in between. That's what the asthenosphere is. So when we're saying that the lithosphere is on top of the asthenosphere, imagine putting this block of wood on top of slime. Can you move the block of wood then? If it's on top of slime pretty easily? Yeah, because slime's ooey gooey and slippery and slimy. So the block is allowed to move because it's on this ooey gooey, slippery, slimy surface. So the asthenosphere is like slime. Let's just keep going with these. We'll just get the vocab words done for today and call it quits and then learn the reference table tomorrow. So the stiffer mantle, which again, can you tell by its name, stiffer mantle, what are we back to? Rock, solid rock now. So the rigid mantle solid, the stiffer mantle solid, but the asthenosphere, which is part of the mantle still, is this ooey gooey, slippery, slimy layer. So nothing much to say about the stiffer mantle. It's located between the outer core and the asthenosphere. All right, the next one is the outer core. I'm assuming you guys remember that there was an inner and outer core from 6th, 7th, or 8th grade. If you didn't, okay, there is 2 layers, the outer core and the inner core. The outer core is liquid. It is completely molten rock that moves around the inner core, creating the Earth's magnetic field. And then finally, the inner core is solid. It's the Earth's magnet. Once you get these vocab words, for those of you who came in late, I do need to see your homework. Tomorrow, we're going to be coloring our reference table. If you have your own colored pencils, you might want to bring them tomorrow. It'll make your life easier and maybe prettier. I will have colored pencils, but they're not the best. And that's it. So again, if you came in late, bring up your homework or your classwork from yesterday.